Well, welcome back. Our topic today is simple differential equations. Now, you might be thinking, what is a differential equation? Well, it kind of gives it away in the name. Obviously, we need an equation, hence the equal sign in this problem. And differential means we need to see a derivative. So basically, all a differential equation is an equation with a derivative in it. Now, we're going to deal with quite a few types of differential equations throughout the year. And today's just our first glimpse at them. And like I said, they're going to be pretty easy and straightforward today. And we'll get a little more in depth in the next couple of weeks. So in order to solve the differential equation, my goal is to solve for y. So I simply say to myself, I'm staring at the derivative of y. So in order to get y, all I would have to do is go backwards or integrate. So I'm going to integrate both sides. So integrate dy dx equal to the integral of 3x squared minus 1. And of course I need a dx there. So again, I have the derivative. My goal is to solve for y, so I'm going to integrate both sides since this is the derivative. Alright, well, pretty straightforward at this point. Like I said, these are pretty simple today. Who do you take the derivative of to get dy dx? That would be y. The derivative of y is dy dx. And then on this side, just make sure you integrate. The integral of 3x squared, of course, is x cubed minus x, and then plus c. No bounds, that indefinite integral should have a plus c. And let's just go ahead and box that in. This actually has a name, and this is called your general solution. Now, 99% of the time, they're going to want you to go a little further and actually solve this for an initial condition. So I'm going to continue on with this problem, and let's say we're given this initial condition of y of 2 equals 4. And basically our goal now is to find the particular solution. Alright, so again, let me just recall this general solution. Basically what I'm saying is, no matter what number I put in place of the c, whether it's a 1, a 2, a 10, a negative 2 million, its derivative will always be this 3x squared minus 1. So now I'm saying, okay, if this general solution has to pass through this point, 2, 4, what is the equation of that curve specifically? So once I found my general solution, it's very simple. I'm just going to plug my 4 into y and my 2, of course, into x and solve for c. So I've got 4 equals 2 cubed minus 2 plus c. 4 equals 8 minus 2 plus c. 4 equals 6 plus c, so c equals negative 2. So all that implies is the particular solution to this problem is y equals x cubed minus x minus 2. And that's it. You solved your first differential equation. Example 2. dy dx equals 4x and f of 0 equals 6. So again, this is considered a differential equation because it's an equation right here with a derivative in it. So differential equation. This over here is the initial condition. They're giving you an initial value. That's implying they want a particular solution to this problem. So, again, in order to solve for y, I'm just going to integrate both sides. And don't forget to slap the dx on this side. So go ahead and integrate. Again, pretty straightforward. And I'm going to box that in. I'm not done here, but this is my general solution. Okay? That means no matter what number I plug in for c, I'm always going to get this derivative of 4x. But they gave me an initial value, so I have to go one step further to get the particular solution. So I'm going to carefully plug in 6 into y and 0 into x. Oops. So c equals 6. And then don't forget to write that final solution out. I've got y equals 2x squared plus 6. And again, that is a particular solution to that given initial condition. Number 3, dy dx equals 1 over x squared, and f of 1 equals 0. So pause it, try it on your own. Hopefully you're thinking it's pretty straightforward. And I'll meet you back in a few seconds. Alright, so you can scroll through my work real quickly. Obviously 1 over x squared is just x to the negative 2. Add 1, divide by 1, and you've got your general solution. Don't forget that plus c. Plug in the initial condition. I've got c equals a positive 1, and plug that value back in, and you've got your answer. Okay, well I've only got 2 more for you, and these are a little different than the previous 2 we did. Not mathematically, you just have to pay attention to what you have. So in question 4, I'm given f double prime of x is equal to sine x. And notice there's 2 initial conditions this time. Alright, so I need to take my time here, and the actual question is to write an equation for f of x. So I have to take my time here. I have f double prime, and I eventually need to get to f of x. Obviously, I'm going to have to integrate, and hopefully if you're already thinking, you have to integrate twice, hence the 2 initial conditions. So I'll start with the first one. I'm going to integrate f double prime of x dx, and I'm going to integrate sine of x dx. So just again, common sense, when you integrate f double prime, you should be getting f prime of x. And when you integrate sine, who do you take the derivative of to get sine? Hopefully you've said negative cosine of x plus c. So I do need to stop here, and I'm not done. I need to get, before I can integrate again to get f of x, I need to use this initial condition for f prime. Okay, so I know when I plug 0 into x, I should get 1. So negative cosine of 0 plus c. Picture that cosine graph. The cosine of 0 is 1, so that's a negative 1. Add that over, and I should get c equals 2. Now again, rewrite your equation. F prime of x is equal to negative cos x plus 2. All right, halfway home. I still didn't answer the question. I need to get f of x. So to get f of x, I just need to integrate f prime of x. And then integrate this side. I'm going to pull the negative out front. Cosine of x plus 2 dx. And again, watch your notation. Don't forget to slap those dx's on the end of each integral. All right, when I integrate f prime, that comes from f of x. And who do I take the derivative to get cosine? Hopefully you've said sine, and I have that negative in front. I'm going to kind of separate my integral there with the plus sign, because obviously when I pulled that negative out, I wasn't pulling it out of the whole thing. So I'm going to get a plus 2x plus c. And now I'll use that initial condition. I believe it was f of 0 equals 6 was given for f of x. So I'm going to say 6 equals negative sine of 0 plus 2 times 0 plus c. Therefore, c is equal to 6. So lastly, I can rewrite my equation for f of x. And it should be negative sine x plus 2x plus 6. And again, that is a particular solution for a very specific initial condition. All right, we've got one more to try, and hopefully you're feeling pretty good about these. Okay, I'm given a of t equals 5t plus 3, v of 2 equals 6, and x of 2 equals 3. And the question wants me to write the equation for position. So again, just a little self-talk. You're given acceleration, you eventually need to get to position, which means you need to integrate twice. So just take them one at a time. So I'm going to integrate a of t dt, and integrate this side. Remember, always balance your equation out. So the integral of acceleration, of course, is velocity. And this will get me 5t squared over 2 plus 3t plus c. And carefully plug in your 2 values. I'm using the initial condition for velocity here. So I'm plugging a 2 into t and a 6 into v of t. And it looks like I get c equals 10. Hopefully you're checking my math there. So I'm going to rewrite my velocity equation now. It's 5t squared over 2 plus 3t plus 10. Okay? Now again, that's only halfway home. My goal is to get position, so I now simply need to integrate velocity to get position. And again, watch your notation with those dt's. So the integral of velocity on my left side here, of course, is position. So I finally have got my x of t. And again, just carefully take your time here. So that's 5t cubed over 3 times 2 is 6, plus 3t squared over 2, plus 10t plus c. And I believe the initial condition was x of 2 equals 3. So I'm just going to jot that down for myself. It was x of 2 equals 3. So I'm setting my equation equal to 3 when I plug in 2. And hopefully your math turned out to be the same as mine. I ended up getting a c to be negative 89 thirds. So lastly, I just need to put it all together. My position is equal to 5t cubed over 6 plus 3t squared over 2 plus 10t minus 89 thirds. And there we have our particular solution for that given initial condition. Well, like I said, this is just skimming the top of differential equations, and we're going to get pretty more involved in it within the next few weeks here. But hopefully, you can pause it, rewind it, do what you need to do, and we'll see you in class tomorrow. Have a great night.